Please welcome Michael, who's talking to us about productionalizing R code using Databricks.
All right, guys, thanks for coming. So just a quick show of hands. How many of you, when you start a new data science project, whatever that is, at work or home, you kind of go straight to your laptop? I don't believe it. Okay, here we go, couple more hands. Or you guys actually plan this out? You have your requirements, your environment spec'd out? No, well, I can go then. Okay, so often what we do is we get some sort of challenge we want. So we'll either have a business problem or we get given a data set and we're just told, do your stuff. And we go away and we do this. And this leads to a problem, right? A lot of these projects are unsuccessful. Now, how many projects do you think fail as a percentage? So who thinks 30% of data science projects fail? Only 30%. 50%? 70%? 80%? Huh? All right. So the answer, in a in-house fashion, is 85% of data science projects fail. Now, failure is a wide term, so this is generally made it to production. So the reasons projects fail, poor requirements, insufficient data, data quality issues, perhaps team resourcing issues. There's a whole bunch of reasons projects fail, but one of the big ones, and the ones that I'm talking to, is obviously that how do we get something from our laptop into a production environment, right? And so a production environment is where the general organization is able to access and derive value from it. It's not running on my PC anymore. Okay, so essentially what we're talking today is how we can move our projects into a production environment, in this case, Databricks. So before we begin, we're really looking at a data science sort of life cycle. Now, we speak to that problem that we started off with, like how do you approach data science? And there's a couple of models, okay? So CrispDM is the sort of legacy version, right? So that comes from the data mining days, which speaks about a number of steps. So, getting your requirements, your data sources. There's Google has one. I must forget, I've sort of forgotten the name. But Microsoft also has one, and they call that the team data science process. And I'm going to talk about that just because it's kind of the most visually sort of understandable. But they're all the same, right? Okay, so when we think about a data science process, am I breaking something? No problem? Okay, so we start with the problem, right? So business ideally come to us with this problem. They say, hey, we're trying to understand our customers in some way. So, cool, that's we need a problem. We need to identify that data science. And this is a two-part process, right? We'll sort of identify the problem. We'll have data. That'll then inform the problem that we have in some ways. Maybe we change our requirements based on the data. Maybe we can form a better question once we've done that research, okay? Once we've sort of dealt with the problem and we've sort of acquired the data, that's when we build the model. And that's generally what we think of our job as, okay? But, until it hits production, okay, you haven't actually built anything useful for your business. So this task of getting things into production has been one of the bigger challenges, okay? And for a lot of reasons, right? If we think about building that R solution on your desktop, right? R is single-threaded. We have a limited amount of memory. We often work with a sample data set, hard-coded values. It's insecure. There's just a ton of reasons why we can't lift and shift that R script that we built into a production environment. There are things that make it easy. I think somebody's speaking about Shiny next, so that's one of the approaches. But Shiny doesn't really necessarily address scale issues, okay? It's just maybe whacking on a bigger machine and whacking a visual layer over it. But there's a lot more that the enterprise require. So for this, we're looking at essentially Spark and Databricks. Now, Spark was not designed for R, nor was it necessarily designed for data science, but it is a very handy platform to sort of build. So we just quickly have a look at the history of Spark, because the history of Spark is actually the history of Hadoop. I don't know how many of you guys remember the big data craze? Like we're in the big data science phase. Big data was the thing 5-10 years ago, right? Big data was going to change the world, okay? And that just didn't happen. And some of the reasons for that is it was honestly kind of slow. That sort of time to insights was too difficult, okay? It took too long. So, but as a history, it really started off with the Google file system. So in 2003, Google built this, or wrote a paper on how to build a distributed file system. So this allowed us to take files and map them over multiple machines. And this allowed us to sort of get rid of that single storage bottleneck that we have with these SMP machines, if you want to call them that. But being able to distribute your storage was only part of the problem. Next we needed to do was distribute compute, and that's where we got MapReduce. So MapReduce had a problem where what we did is we took the problem, we divided it into lots of little pieces, and pushed it out. A new sort of product got built from that, and that was called Hadoop. So many of you have probably heard of Hadoop. How many of you guys are actually running Hadoop in some scenario? You guys are either non-reactive or nobody's using Hadoop? One little wave in the corner. I saw you. Okay. One person's using Hadoop. Okay, so Hadoop had all these problems. It was big. It was slow. Okay, so again, the guys out of Silicon Valley built a new product called Spark. And Spark was this, it was kind of like Hadoop, but in memory, right? Okay, everything was fast and everything was distributed. So some of the properties of Spark that have become pretty important. And this is where the first one is really what makes it work great for R, is that it was built on this idea of a data frame, which is what, our people, we work with data frames. So we had this natural ability, this natural mapping, and it wasn't a mistake, right? The Spark guys looked at what the R guys were doing here, and Python guys, and saw that these data frames were working. Okay, but it's got a couple of other features we can't use in R so much, but we got a streaming APIs, graph APIs, and machine learning libraries, right? Okay, so this gives us this platform that we can sort of distribute our code onto, and then so shortly after that, guys formed Databricks, because everybody knows you don't make money out of building things for open source communities. You build a service company and you sell the services out of that, right? So the Cloudera guys, this is where the money is. Okay, so simple architecture for Spark. It uses two main concepts. The first is this idea of a resilient distributed data set. So this is this in-memory data set that gets distributed in amongst all the nodes. So because it's in memory, it's sort of fast. You don't have to worry about any of the mechanics sort of behind it. And the next thing is the directed acyclic graph. And this is really where it gets a lot of its speed from. It's something we found in Hadoop and John's the R community as well. Is how when you're preparing data, you sort of prep one column at a time. So you make one transformation, then you run it and save it, persist it to disk, then pick it back up, another transformation. And that actually takes a lot of time because you're actually doing all of these things one step at a time. So SQL will call it rebar, so row by agonizing row, okay? Versus this directed acyclic graph essentially stores all of your intent, and then at the last opportunity to actually perform all these tasks, that's when it does it, right? So, save all of the things you want to do, and only when you actually make a call to that data frame, and it realizes that data frame is not already in memory, it would then go and execute that graph. So speeds work up quite a lot. An architectural level, essentially we have Spark core at the bottom. So this is all the infrastructure. And then with the resilient distributed data sets above that. So that's the distribution of that data across the nodes. Then we have the analysis APIs with all the services, right? So we spoke about graph, streaming, and library. The one that's important to us is the Spark SQL, which is what derives these data frames. Okay, and then we get higher level languages on top of that. The one that's really important to us is Spark R, but there's actually two libraries that you really want to use. There's Spark R and Sparkly R, okay? Not very creative. Sparkly R is probably the one you're going to want to go to. It's not natively loaded, but it comes with all the cool stuff you want. dplyr, tidyverse, right? If you want all of that stuff, you're going to look at Sparkly R. But incorporating it is as easy as just import module, right? Package. All right, huh? Okay, you guys all know that I'm not actually an R guy, right? Okay, so I'm an infrastructure guy. Okay, so how does Spark work? Essentially, we have a driver. Typical distributed system, you have this head node that runs the Spark context. There's a cluster manager that spins it, controls how this job is distributed amongst all the nodes, and it's pushed out to a whole bunch of workers that actually do the thing. And this is how we get scale, right? Because we can scale up to thousands of these nodes. If you're doing your work over petabytes of data, a single laptop just isn't going to do it, right? So that's where we need these clusters, and these clusters handle the interaction with the data sources themselves. All right. So all of this is really hard. I don't know if any of you guys have ever tried to spin up a Spark cluster. Anybody here? One guy, 3, 4, 5 guys. Nice. Okay, and pleasant experience? not a pleasant experience, right? Especially if you're like me, I'm not, in addition to not being an R guy, I'm also a Windows guy, right? So my life is really hard. Bash isn't something I'm particularly familiar with. So yeah, it's really difficult. So that's where Databricks comes in. And Databricks makes all of this process really easy. Okay, now one of the big things with Databricks is that it is a cloud-only implementation, right? So it's not going to work in your local implementation. So you have two options. You can spin it in AWS or Azure, right? So you really have to choose your flavor. If you are looking for a free one to trial, I suggest you go AWS route. Okay, they actually have a free tier. Okay, but if you're looking for a lot of those enterprise features, enterprise security, okay, the Azure route is probably the way you're going to look at going. But a lot of them, both of them are great, right? And 99% of the features are the same. Okay, so why Spark? Well, first off, it's one environment for the whole team, right? So your data engineers, your data scientists, your business analysts are all using the same portal. So there's not one guy that's managing the Hadoop and your typical data engineering things, cleaning the data, sourcing it, prepping it, and loading it in via some lake. Then there's the data science comes in some other process. We're all accessing exactly the same portal, which makes that move to production really easy, because the truth is we're actually developing in a production-like environment. We're never trying to figure out how to take something from our development space and put it in production. As I mentioned, one-click deployment, okay? One click and a credit card, of course. Okay, so really easy to get going. All you really need is a name. You're going to choose essentially what sort of base you're going to want. You're going to choose the size of your cluster. Many options. We get to choose the kind of cluster that we want, okay, which really loads up into our scale. So we have interactive clusters that are pretty much on demand, or we can leave our clusters running essentially full time. So if you have that kind of workload where you need this thing running all the time, you can scale these things up, but we can spin them up. We can add additional nodes, scale them down. Nobody does work over the weekends. We can scale it right down, scale it right up on a month end, right? So you've got that ability to scale in near real time, okay, which is really handy. Security, one of the big things we tend to forget about, even Shiny. I think Shiny doesn't come with any security in the free version, right? As with many tools, right? Security is hard. Okay, these guys have solved that for you. And if you're plugging into something like the Azure version of Databricks, that's going to integrate into your Azure Active Directory, right? So everybody who's using Office 365, any other Azure services, that is just going to be a seamless experience. How do we develop? Okay, well, we've got interactive notebooks. Okay, so interactive notebooks are, I think we've all used sort of Iron, Python, Jupyter sort of notebooks experience to develop, and that's exactly what it is here. Okay, you'll notice it supports a lot of languages. So there is nothing inside Spark that is directly attached to R, but R just works on it naturally. Okay, so your jobs will scale, and you can develop. Most of your packages work. Okay, so obviously your mileage may vary there, but works pretty well. Okay, and then the most important thing, and I'm going to leave this one till last, is essentially RStudio integration, right? You guys are, a lot of you who's here uses RStudio for all of their development. All right, a lot more hands there. Okay, so you do not need to leave the environment that you love, right? So you can do all of your development for your Spark projects within RStudio, okay? And all of that will then just scale across the cluster with no real sort of configuration with yours. If you have RStudio Pro, okay, you got who's RStudio Pro integration? You can, nobody? Not a single person? Right? You need to get an RStudio a salesman in here, okay? So essentially you can port those licenses over, and you can just migrate your whole experience over to that, getting that sort of seamless experience, right? So not a single line of code this year, and no live demos. Yeah, any questions? I think that is my time. All right.